All right, so what I'm gonna do here is I'm gonna go ahead and draw for us a little inverting amplifier example problem. Oops. Draw our minus plus like this, and then I'll ground the plus terminal, and I'll give myself another resistor for feedback here. Let's make this one 6K, and let's make this one 1K for our resistor values. And then let's go ahead and give ourselves let's just give ourselves a 1 volt input voltage, okay? And so what I'm going to do is I'm going to go ahead and go through the same process we went through last time where I derived the expression, and then I'll just use that expression at the end to plug in values. It's important to know how to solve the problem without just using the expression, just in case you can't figure out how to recognize the inverting versus the other topologies that we're going to look at. Obviously, if you get to the point where you can just recognize them and memorize the equations, that's great. But in case you can't, it's good to be able to use the op-amp golden rules and just go ahead and solve the circuit using what we've learned in this class so far. So first and foremost, the plus terminal is grounded, so I have 0 volts there. Using golden rule number 1, I know that this entire node here is the minus terminal, right? And I know that my plus terminal and my minus terminal have to be at the same potential. So I can write that this node is also 0 volts, okay? Well, what else do I know? Using the golden rules, I also know that no current can flow into this minus terminal. So let's keep that in mind, that any current that flows here is going to end up flowing here, ultimately, through this resistor. None of it's going to flow into the minus terminal of the op-amp, okay? So let's keep that in mind, and let's go ahead and write an expression for this current I1 and an expression for this current I2. We can set them equal to each other, and we can solve for V out. This node here is V out. And what is the voltage here? Well, if I have ground on this side of the battery, and then I know it's a 1 volt source, then I know that my voltage here is 1 volt. Okay, so let's come up with an expression for I1. I1 is going to be equal to V over R in this case of this resistor, which in this case it's going to be 1 volt on this side, 0 volts on this side. So I can write 1 volt minus 0 volts divided by 1K. Oh, I picked the wrong pen. Whatever. I'll just continue the problem with that one. I2 is going to be looking at the second resistor, right? It's going to be the voltage drop across that resistor, which is going to be 0 volts minus V out divided by 6K. 0 volts minus V out divided by 6K. Okay, so now we can set these two things equal to each other. I1 is equal to I2, right? That current and this current are equal because no current's going to flow here. So let me go ahead and do that. 1 volt over 1K is equal to negative V out over 6K, and I can just multiply both sides by 6K and a negative, and I get negative 1 volt times 6K over 1K equals V out. The K's cancel, and I get negative 6 is equal to V out. All right. And so let's see, how does that compare to just using my equation from the previous slide? Let's go ahead and pull that equation in, and we can compare. So I'll just throw that equation over here. If I were just going to use this equation, I would evaluate this at V in is going to be 1 volt here. R1 is going to be 1K, and RF is going to be 6K. So let's plug those values in. I get negative 1 volt times 6K over 1K. K's cancel, and I get V out is equal to negative 6 volts. Okay, so that just proves that solving the problem the long way and solving the problem the short way is equivalent. Of course, it's important to just be able to analyze the circuit like this on the off chance that you can't recognize the type of amplifier topology. If you can always use the expression that we've derived and just plug in values, and you'll get the same answer, and we can see that, right? Okay, so that's our inverting amplifier example. In the next video, I'm going to talk about a special case of the inverting amplifier, and then in the following videos, we're going to get into the non-inverting amplifier topology.